just going to learn two ways of proving triangles congruent. When triangles are congruent, they have 6 congruent pieces. Have 6 congruent pieces because they have 3 angles and 3 sides that are congruent, so 6 total, right? 3 sides, 3 angles. However, we don't need to know all 6 pieces to be able to prove triangles congruent every time. We're going to be making these notes that show us 5 ways that we can prove triangles congruent without knowing all 6 pieces. We can just know sets of 3 pieces that will also do the same thing. The 2 we're focusing in on today are called SSS, which is side, side, side. And that means that if 3 sides of one triangle are congruent to the 3 corresponding sides of another triangle, then the triangles are congruent. So you can see in here, we know the triangles are congruent by side, side, side because we have a side congruent to a side congruent to a side, and another side congruent to a side. Notice how I've labeled the corners with letters and I've written a congruent statement. Triangle ABC is congruent to triangle FED. I make sure and line up the corresponding angles when I write those congruent statements. The other one I want you to be aware of today is called SAS, which stands for side, angle, side. Here's our actual definition. If 2 sides and the included angle of one triangle are congruent to the corresponding sides and included angle of another triangle, then the triangles are congruent. Included angle was in that definition, so let's talk about what included angle means. The included angle is the angle that's between the 2 sides. So you can see in the picture I've drawn here, I have a side congruent to a side, an angle congruent to an angle, and a side congruent to a side. And the angles that are congruent are the ones that are between the 2 sides, that it's actually like those 2 sides are forming that angle. Okay? Then there's a couple of things that do not work to prove triangles congruent. Angle, angle, angle does not work because you could possibly have 2 triangles that are the same angles but different sizes. We're going to talk about this in next chapter. We're actually going to call these similar triangles, but not congruent, because if they're not the same size, even though they are the same shape, they are not congruent. So AAA is not a valid way of proving triangles congruent. The other way that does not work to prove triangles congruent, I like to call SSA. Be cautious spelling it the other direction, although many a high school student likes to get a snicker out of that one. But notice my picture here, how I have a side congruent to a side, another side congruent to a side, and an angle congruent to an angle. But this time the angle is not between the 2 sides. So since it is not this angle between the 2 sides, it's down here instead. It does not restrict what angle that has to be right there. So see how this angle is going this way, whereas that angle is going that way. So we end up with a larger triangle and a smaller triangle that have the same side, side, and angle. Because of that, we cannot use angle, side, side, or side, side, angle to prove triangles congruent. So when that happens, we just say that it's not possible to prove them congruent. There is actually an exception to this that we will learn in a few days, and it is the H-L Theorem. And it works only for right triangles. Because when we have a hypotenuse and a leg that are congruent and it is a right triangle, technically we have side, side, angle. But in the case of a right triangle, it works. If the triangle is not a right triangle, then it does not work and we cannot use it.